Math students, welcome to our first day of our 3D geometry unit. In this video, I'm going to give you our first lesson, but before I do that, I'll also give you just a quick overview of what we're going to be doing the next couple days as we go through this 3D unit. So in this unit, we'll have a lesson that's going to go through today on the basics of what the unit's going to cover. We'll hit some key vocab so that when we're talking about different terms related to 3D geometry, you know what those terms mean. And then we'll have a couple lessons that are going to be focused on finding the surface area of various three-dimensional figures. And then finally, if we're doing 3D, we got to be doing volume. So we're going to be doing some lessons on finding the volume of various three-dimensional figures. So now you know what's coming down the pike. Today, however, we're going to be focusing on some vocabulary. So the words that are over here on the left side of the screen are what we're going to start with. It might be a good idea. I know that we're doing school from home for now, but if we were in real school, you would be taking notes, and it might be a good idea to do that. Get a notebook out, make it feel a little more normal, and sometimes writing things down is another way to help solidify it in your brain. So yeah, you might be listening to the lesson, but it also might be a good idea to make yourself some notes. It's your call. I would advise it, but here we go. Faces, edges, and vertexes. These are all words that you should know and understand, and I'm sure some of you already feel comfortable with these, but just in case, here we go. The first is face. What is a face? Well, a face of a three-dimensional figure, and I'm using this figure here, which is a rectangular prism, but we could be talking about any three-dimensional figure. The faces of a figure are all of the flat, hold on, there we go, flat surfaces. Sorry for my handwriting, it's hard to write on this, but all of the flat surfaces. So if I was to maybe color one of those in, like one of these sides, this flat surface, this is a face. This figure has 1, 2, 3, 4, 5, and then the front. So I've got a mark that's on the back face there and a mark on the front here. That would be 6 faces, all of the flat surfaces. Cool, so sorry about that. That's the faces. Edges. Edges are the line segments. So line segments where two faces intersect. What does that look like? Well, that's pretty straight. This is an edge. Why? Because this bottom face and this front face here intersect at that point. That is an edge. In this shape, you could count the edges. There's 1, 2, 3, 4. And on the top, 5, 6, 7, 8. And then we've got 9, 10, 11, 12. We've got 12 edges in this rectangular prism. And then finally, we have vertexes, vertices. You might hear them, that's the plural, vertices. A vertex. What is a vertex? A vertex is a point where 3 or more edges meet. And visually, since sometimes it's easy to visualize that, this is an example of a vertex. A vertex is where 1, 2, 3, at least 3 edges meet up. So this is a vertex, this is a vertex, this is a vertex, vertex, vertex. So in this rectangular prism, there happens to be 8 vertices, 1, 2, 3, 4, 5, 6, 7, 8. But there's your basic vocab. A face, all the flat surfaces. An edge is any of the line segments where the two faces intersect. And lastly, a vertex is a point on a three-dimensional figure where three or more edges meet. You're responsible definitely for knowing what those words are and being able to identify them in any three-dimensional figure that you might come across. So that's the first part of today's lesson. The second part of today's lesson, I like to think of this as the three-dimensional shapes, at least for our 6th grade unit, family tree. It's a very small family tree, but we are going to be talking about, in this 6th grade unit, polyhedrons. Now, you don't really need to know that word, but the two main types of shapes that we will be talking about fall into the family of shapes known as polyhedrons. So what is a polyhedron? Well, this rectangular prism is an example of a polyhedron. Why? Because polyhedrons are any solids whose faces are all polygons. Now, there's a lot of words in there, so I'm going to rephrase that with simpler language. A polyhedron is any solid whose faces are faces that are shapes with edges. AKA, we will not be doing any shapes that have to do with circles. So we won't be doing spheres in this unit. We will be solely focusing on shapes with faces that have straight edges, known as polyhedrons. And polyhedrons fall into two main categories, and those categories are on the screen now: prisms and pyramids. And we're going to talk about the difference between the two, because you need to be able to look at a shape and be able to tell what it is. And you can tell what it is if you know the key characteristics of a prism and the key characteristics of a pyramid. So on the screen, I'm giving you a visual example of one type of prism. There are many types of prisms, but there's one on the screen. And what makes a prism a prism? Well, I'm going to give you three different characteristics that you can use to identify a prism. Key characteristic one is two bases. The key here is two. Prisms have two bases. And how do you know what is the base in a prism? It's not the side that it's sitting on, because then you would think it's this large rectangle on the bottom. That's not the base. A prism base can be identified by, first, what are there two and only two of, but more importantly, the bases are always parallel from one another. So in this shape, the base is a triangle. Why? Because there are only two triangles, they are identical to one another, and they are parallel from one another. So base 1, base 2. So one thing about prisms is they have two bases. If you see something with two bases, you know it's a prism. Another characteristic is the non-bases. So I'm going to call those the rest of the faces. The rest of the faces, which in this shape, here is one of those, I'll kind of color over it. The rest of the faces, using all the wrong words, are all parallelograms. So in a prism, you've got two bases. They could be any polygon. Triangles, hexagons, pentagons, trapezoids, as long as they're straight sides. But the rest of the faces must be parallelograms. Typically, you will identify them as rectangles, the rest of the faces as rectangles, but a rectangle is a type of parallelogram, so I'm using more proper terminology here, but the rest of the faces are rectangles, or also known as parallelograms. And then lastly, a little hard to see down there, the name of the prism is always based off of the base. Whatever shape the base is, that's going to be what the name of the prism is. So this prism right here has a base that's a triangle, so therefore this is a triangular prism. If the bases were trapezoids, it would be a trapezoidal prism. If they were hexagons, it would be a hexagonal prism. The name of the prism is always based off of the shape that is the base. So those are 3 ways to identify or important characteristics about prisms. And since my handwriting is super sloppy, here that is summarized for you in nice clean writing. If you're taking notes, you can pause and write that down. The other type of shape is a pyramid, which there is now one on your screen. And we're going to talk about the 3 characteristics of pyramids. How can you tell if something is a pyramid? Well, first thing, let's talk about that base. There is only one base. And the base can be any polygon. Any polygon can be the base. In this shape, it looks as though it's a square or possibly a rectangle, but it could be anything. That's the base. But there's only one of them. That's the key characteristic of a pyramid. There is only one base. And number 2, this is also super important. The rest of the faces are always triangles. So pyramids have triangular faces and then some sort of polygonal base. And similar to a prism, it is named by its base. So in this, I've got a rectangle as the base. This would be a rectangular pyramid. If I had a hexagon as the base, it would be a hexagonal pyramid. If I had a trapezoid as the base, it would be a trapezoidal pyramid. So the name of a prism and the name of a pyramid is always named after its base. The only differences between these 2 shapes are in a prism, there are 2 identical parallel bases, whereas in a pyramid, there is one base. In a prism, the non-base faces are all parallelograms or rectangles, if you'd rather. Whereas in a pyramid, the rest of the faces are triangles. And they all meet at one point at the top, one vertex up at the top. Some people will call that the apex. And then for both shapes, they are both going to be named by the base. So those are some key things to pay attention to. Cool. So I think it's always helpful for some of you, like, well, what do I need to be able to do? What am I going to be quizzed or tested on or have to do homework on? You should be able to, from this lesson, number 1, look at any 3-dimensional polyhedron and tell me how many faces, edges, and vertices that solid has. And secondly, could you then name the solid? And when I say name it, I mean complete name. Is it a prism or a pyramid? And what type of prism or pyramid? So let's do one example together. I don't think this is that challenging, but it's still good to look at together. So here, we could name this first if you want to. I know for sure that this has to be some type of prism. How do I know that? Because there are 2 bases that are parallel and identical from one another. And those have 1, 2, 3, 4, 5 sides. So this would be a pentagonal prism. Some people will pronounce that pentagonal prism. So we've named the shape. It's a prism. What type of prism? Pentagonal. How do I know? Because that's the base, and prisms and pyramids are always named after their bases. And then secondly, we're going to be talking about the number of faces, the number of edges, the number of vertices. So let's figure this out. Well, the faces, there's 1, 2. There's 2 bases, so we'll keep track. 1, 2. And then the non-base faces, well, the base has 5 sides, which means there has to be 5 faces coming off of that base. 1 on the front here that we can clearly see, and then there's these 2 on either side of the front one. And then you kind of have to look through the shape. There's 1 face coming off of this edge and 1 face coming off of this edge. So in total, there are 2 bases, those count as faces, plus there are 5 more non-base faces. So in total, this shape has 7 faces. All right, how many edges do we have? Well, we've got 5 on the top, we've got 5 on the bottom, so we're already up to 10. And then we've got 1, 2, 3, 4, 5 coming off of connecting the 2 bases. So in total, there are 15 edges in this shape. And then lastly, how many vertices are there? Remember, a vertice is the point where 3 or more edges meet. So there's 1 here, 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 and here. And then there's 1 in the back there. We're like looking through the shape. And then there's some here. So in total, I have 10 vertices. And that's what you'd be responsible for today. We're done with the lesson. I also thought it would be slightly interesting, maybe nerdy, to just bring to light that, yeah, it's school and geometry and whatever, but geometry is cool because it's everywhere. Like, I'm sure a number of you, if not maybe all of you, have walked through New York City past this building, or at least seen or heard of it. This is the Flatiron Building, and it's pretty cool. It's well, you tell me, what type of shape is this? I know that we can't actually be having this discussion, but if you're saying it at home, it's a triangular prism. It's kind of cool. It's got 2 triangular bases. It's got these huge rectangular faces smack dab in the middle of New York City. Very interesting. And then, I don't know if you've ever gone to any cool ruins. These are in Mexico. This is a very famous archaeological site. This is the Pyramid of the Niches. It's made up of a lot of different geometric 3D shapes. It's really cool. Anyways, I'll leave you with that little nerding. Enjoy your day. If you have any questions on the work, feel free to message me or pop on the Google Meet later today, and enjoy your first day of 3D geometry. Happy day, people.